Hello everyone, welcome to Study Table. My name is Swati, and in this video we'll be talking about RESTful API. What REST is, what does an API mean, how does it work, the introduction and the advantages of it. So if you are new to this channel and you have not yet subscribed, I would like you to please subscribe and hit the bell icon so you do not miss any further updates from the channel. So without much ado, let's start the video. So we'll talk about what is RESTful API. So before we understand what RESTful API is, we have to first understand what is REST. So REST stands for Representational State Transfer, which is the acronym of REST, and it is a standard or the architectural style for providing standards between computer systems on the web. If two systems are connected to each other, let's say I am a browser and I want to see something on the internet, so I'll raise a request and I'll expect a response from the server. Okay, so the connection happens over HTTP, which is a protocol, and that protocol used by REST is also HTTP. So when the connection happens, there has to be some common terms that both the parties have to agree, more like a protocol. At like for example, if a delegate comes to your country, then there is a protocol that has to be followed, that how the person will be attended and what are the rules and regulations that has to be followed for the delegate has arrived. Similarly, if we are talking on the internet to some server or to some other client, then there is a set of rules that has to be followed, and the set of rules is defined in REST, and both the parties have to follow that. So REST is a kind of an architectural style in which the two computer systems talk to each other, making it easier for the systems to communicate with each other, because the REST already specifies that how the communication needs to be done. Okay, this can be a little confusing now, but more in the video you will understand what exactly it means. Okay, so we'll cover the detail of it in the video ahead. So let's move ahead. That is the what does the meaning of the state. If I'm talking about representational state transfer, then what is the meaning of state? See, state can be confusing to you. If you are a science student, then you must have heard about the state of solid, liquid and gas in science. But what is a state? In physics, we learned that state is a condition in which a thing is until and unless and for external forces applied on it, right? But if we talk about the computing system that is in a web application, state refers to the current condition, that is the condition in which the object or the condition in which the page is. Let's say for example, I want to book tickets for my upcoming let's say I want to go on a vacation and I want to book a ticket for me. So I'll open my browser and start booking my ticket. Though my state is the client state, that is the browser is currently opening the page of the server that I want to connect to. So I'll raise a request ki, okay, I want to go to this website and I want to book my tickets. So the server state is that the data is saved into that server, that is okay, this is the these are the flights and this is the cost of the ticket. So the server state is that, and it's in the form of some data that can be in the form in a database, it can be in form of a table. But as soon as I want to access it, then the server sends the response back to my browser, and that browser displays it in some format. So the state changes from the server state to the application state. That is, now the data is being presented to me in some format, maybe in the HTML format, in the XML format, or in JSON format, the format which I want to see. If I'm seeing it in the browser, then the most common is I'll see it in HTML format. But if I want to access it onto a table, then I'll see on a table format. So this is referred to as state, that is the state of the object that is initially, and when that object is called, then it changes the state from the state it is in to the state it is being called to. And the client when raises the request, in the HTTP headers that it raises the request, the format in which the data has to come back, the format is already defined there. So state changes from the server state to the application state or the client state. So state is nothing but the condition or status of the application as a specific point of time. That is the point of time it is being called. Then the state changes from the server to the client, and you can easily view that. So it encloses what? It encloses all the data, the variables that determine how the application behaves and what it displays. So if I am calling the website of, okay, I want to book a ticket and I'm going to some, like let's say make my trip, then I'll see the list of all the flights that are available with the cost of that flight. Okay, so what, how is it happening? That my request is going to the server, and the server is looking into that. Okay, this is the data that needs to be sent. So if it's saved in a database or something, then it will query the different airlines. Okay, this is being called, and the data will be collected, and it will be passed into some format and then presented to me in the HTML page. So the state changes from the database state to the application state within the HTML page. So this is the just the state, the condition of the application at a specific point of time. Okay, I hope this is clear. And the next is what is stateless. So you understood state. So in a normal TCP connection, let's say if I am connecting to a server through a TCP connection, then when the connection happens, then a handshake happens between the client and the server, and whatever the client has requested, it will be stored on into the server. Whatever request has been raised, all the requests will be saved in the server. Okay, this client uh, requested this, let's say a couple of days ago, and now it's requesting this. So all the client requests will be saved onto the server. That is a full method. Okay, but the stateless method is, this is a communication method. Initially when we saw state, state was a condition, but stateless is a communication method. That is a method of HTTP in which the server completes every client request independently of the previous request, which means it will not save any of the client requests into the server. Okay, nothing will be saved on the server. Whatever I want to request, I will have to send all the data along with the request, so that the server understands, okay, this is being requested, and it sends back the response, and this will not save any of the data, any of the client information into the server. So every time that a new request is raised, it is fresh, nothing is saved on the server. So the server doesn't know, okay, this client has already requested this. So every time a new request is raised, the request is completely fresh. So server doesn't save anything onto the server, and this is called as stateless. So client can request resources in any order because the request is stateless or isolated from all the requests, because it's not being saved anywhere. So the next concept to understand is the API. So after that, we'll come to RESTful API, that what exactly RESTful API is and what are the advantages of it. Okay, so API is the application programming interface, which is a set of definitions and protocols that allows software applications to communicate to response and requests. So if you're going to a restaurant and you're ordering food, then you can either go to directly to the kitchen and order from the to the kitchen staff. But if everyone goes to the kitchen staff and orders, then the kitchen staff will get fed up and, okay, I cook food or I take orders. So a middleman is there, which is the waiter, who takes the orders, goes to the kitchen, comes back with the food and gives it to you. So that's our API. That is an interface in between the client and the server. That is, it defines that in what order, in what way the request and the response should be done, and in what way should be handled. So there are set of definitions that will be followed, and it's a kind of a protocol, that is the set of rules that both the parties need to follow to raise a request and to give back the response. Okay, the communication can involve what? Then communication can involve sending and retrieving data, any kind of data. If I want to access my social media page, then I'll give some data and I'll get back the page I requested. Okay, interacting with other components and performing different tasks like booking something or playing games or any other thing that requires a request and a response, and the API handles in between. But how do you know you are interacting with the API? So if you see a weather widget in your phone, you can either directly go to the weather website and check, but widgets are given into your phone in which you can check the current weather and what is the weather after 7 days, and you can also check the current status also. So these widgets are kind of an API that go to the weather website only and collect data. But instead of you going to that website and collecting data, the weather widget helps you out with that by doing the same and presenting you the current weather and making it easy for you. Okay, you don't go, I'll do that. So that's an API. Okay. Other example can be social media logins in pages, like if you have studied in Udemy and you have taken a course, and you must have seen that they allow you to log in using your Facebook or using a Gmail also. So how do you do that? It's a kind of third party application where they access your credentials and they authenticate you. You can also choose your own password and authenticate you based on that, and they can let you log into the social media logins also. That's also an API. Travel bookings, where such as Make My Trip or Good or other travel agents who show you the list of all the airlines available. So how do I do that? They query the parent website and then give back you the details, acting as an intermediary, so that you do not have to go to every page and check. So they make it easy for you. And the streaming services, different streaming services where you can see many contents in one go. So this is the end of an API. Okay. Now, once the concepts are clear, now we'll understand the principles of REST architectural style. Then what is the REST exactly, and what are the set of rules that REST imposes, and if you have to use the REST architecture, then what is that you need to understand, what is it that you need to do, and what are the features it offers you. Okay, the principles of REST architectures are uniform interface. That is, so if you are creating an application using REST, or if there is a website which is using the RESTful web service, then whatever data that you want to access from it, it will be displayed to you in a specific format. That is, it's not that some data will be displayed in some format and other data will be displayed in some other format. No, the data will be displayed in a standard format or in a specific format, and the formatted resource is called a representation. That is, if I want to access an image from Google, then the image may be saved in the database as .jpg file, but if I want to access it in my HTML page, then it will be displayed in my HTML page. That is it will displayed in a standard format, and that will be the representation of that image in my browser. So this is called as representation in REST. That is representing the resource that I want to access as a response. So that is the representation there. And like for example, server can store data as text. That is, if I want to access something and it's saved as text in the server, then if I want to display it in JSON format, then it will be displayed in the JSON format. So that is the representation of the resource, that is as from text to JSON. So this is the uniform interface, that will the data will be displayed in a standard format, the format that you want, or the format that the browser understands. Okay. The next is statelessness. In the REST architecture, the REST follows the HTTP protocol. HTTP is a stateless protocol. That is, it does not save anything on the server. Whatever client has requested, the request is always new with all the metadata that is needed to access the resource. And stateless, and whatever is being called, the server never saves it. So in the REST architecture, statelessness refers to a communication method in which the server completes every request independently of the previous request. Okay, so it doesn't refer to any previous request because it's never been saved on the server. And every request is fresh, every request is new, and is independent of the previous request. So client can request resources in any order irrespective of the previous request, and every request is stateless and isolated from each other. Okay. Next is layered system. Layered is, the client can connect to other authorized middlemen between the client and the server, and it will still receive responses from the server. That is, maybe a client has saved its application on server A, stored the data on server B, and trying to access it from server C. So the client will not know that which server it has called. It can call the those servers are authorized. So the, like in layered system, the client can connect to other authorized servers. Whatever servers have the authority, to connect to the application, then the client can connect to each and every authorized server in any order, and he do not necessarily have to know the location of it. So it can still receive a response from the server, that is whatever is being called, because the REST API, RESTful architecture supports layered system. Like the server can also pass request to some other server. Let's say if your a web server can pass request to an application server, or your server can pass request to some other server on such as AWS, so it can access data from that, and then it will display it to your browser. So layered system allows you to connect to multiple intermediaries in the way, without having you to know ki which server is being called upon, as long as they are authorized, and you will still receive all the responses that you want. Okay, so we can also design RESTful web services to run on several servers with multiple layers, such as application layer is different, security is different, business logic is different, database is different. So we can connect different servers, and we can still talk to all of them, and all of them can connect to each other using the layered system. Okay, because the layers remain invisible to the client, he does not have to necessarily know which layer is being called upon and how is it working. So with the help of the support of layered system or the layered architecture, different servers can be accessed, and different layers can be different layers can work in collaboration with each other. Okay, the number fourth is caching. Caching is what? Caching is the process of storing data on the pages of the client to save or reduce server response time. So what does that mean? It means that whenever you request something from the server will not store, but it needs to be stored somewhere. Because let's say if I want to see some images, okay, so I have called the server and show me these images. The images being shown, the server is not saving anything. If it's not being saved anywhere, then every time I'm accessing the same site, every time the request is being raised from my side to the server, and it will take bandwidth, it will take time, and also if there are 10 such requests to the server will be bombarded with these requests, and the server time will slow down, and also there will be a lot of load on that server. Okay, plus the client will also have to wait a little longer, because a lot of requests are being raised in the same manner, because server is not saving anything. So the server load is increasing, server time is increasing. So to reduce this, caching was there in REST, which means ki the client, what common things that are being called to the from the server, they will be saved in the client machine as in some place called as a cache server. That is the every time I visit a page, every time I'm accessing something, a part of it will be saved. Okay, so if I'm accessing that page again, then the my browser will first check the cache ki, okay, if this part is available here or not. If it's there, it will display me the image. If it's not there, then it will go to the server and get that image. Okay, so caching is what? Storing whatever is being called initially to a place, so that if it's called again, then instead of going to the server and getting that image again, first check the cache, first check that place if the image is already present there. If it's not, then we go to the server. Okay, so for what does it, how does it help? It saves the server response time, that is the server is not bombarded with much requests, the server response time is improved, and also the server load time is also reduced. Okay, examples such as if I visit a website that has a few images on every page, that is let's say if I'm surfing Mintra and I want to purchase some dress, then on every page there are a few images, some images may be common. So if there are some images on every page, then every time if I visit a new page, and the server must resend the same images to me, so what does it happen? The client will cache or store these images after the first response, that is after the first page is loaded, the common images are saved, and every time when I click on the next page, then the common images will be loaded from the cache and not from the server, and this will help the reduce the server time, that is down, doesn't have to go to the server and say ki, okay, give them the image. No, it's there on the cache, so server the time will be reduced. Okay, next is code on demand. So servers can temporarily extend or customize client functionality by transferring software programming code to the client. Let's say if you're filling a form and there's some autocorrect happening, you have written some spelling mistake, the autocorrect tells you, okay, this is wrong, please correct this. Or if you have entered a wrong date, then the date which doesn't exist, then the server tells you, okay, this date is wrong, this doesn't exist. So the any mistake is highlighted on your part if you have done. So this happens to code on demand. That, like say if you're filling a registration form, the browser highlights any mistakes that is on your side, that is incorrect phone numbers, incorrect dates, spelling mistakes. So why? Because this is by the code sent by the server. Okay, this is the code that I'm sending you. If these are some common mistakes and this is the format that it has to happen. So if there is some mistake, please tell them that this is the mistake and they need to correct this. Okay, so these are the 5 principles of REST architecture, and all the applications which need to implement the RESTful web service, they need to follow these 5 principles. Okay, so once we have implemented our RESTful API, so what are the benefits that the architecture gives us? So what does that benefit? It gives us the scalability. That is what. So how does REST implement scalability? That is through the stateless nature. So whenever we through its stateless nature, that is key, whatever request is being raised on the client's part, nothing is being saved on the server. Okay, the rest is inherently stateless. So let's say if there is a lot of requests on a server and the server load time is increasing, so we can spin up another server and start to control requests from that server. So that server does not have to know the previous request whatever happened or about the knowledge of the another server. So this stateless nature helps us to implement scalability, because we can raise as many requests, we can handle as many requests as possible on our server, because if we can raise as many servers as we want based on the request, and all the servers can work together and give us the response, because of the stateless nature, the server does not have to understand, or the server does not need to know what were the previous requests and what are the different servers available. So this helps in scalability. Flexibility: because of the layered architecture, different servers can connect to each other and talk to each other. So migrating data from one server to another server is easy in REST. That is, you can, if your server needs to go from one server to another server, if you're migrating your let's say your website from one server to another server, then in the RESTful world, in the RESTful architecture, it's easy, and because it's flexible, because of the layered architecture, and also because of the use of statelessness and independence. That is, whatever you are uh, implementing on the client side, on the server side, both are independent. You can create a client application in a different language, and you can create a server application in a different language, and both of them can still talk to each other, because both are independent of each other. Okay, so this flexibility of creating independent applications in different languages and still being able to interact with each other using APIs is very helpful in creating scalable, flexible, and different modules, independent applications. So these are the benefits of REST that REST gives you if you're creating your application using the REST architecture style. Okay, and if you are raising a REST request from your client to your server, then what are the contents that your REST request should contain? So the contents is the URI, is the uniform resource identifier, which includes what? Which can include the URL, what you want to access. If you want to access Google, then my URL will contain www.google.com/ whatever image I want to access. Let's say I want to access an image, then the URI mostly will contain the URL of the page. HTTP method, that is, if I want to just view the page, then that will be a get request. If I want to, let's say, post something on my, let's say, on my social media account, if I want to book a ticket, then it will be a post request, because I am now interacting with it. I just don't want to view it, I want to interact with it. I am entering something, I'm interacting with it, then that will be a post request. So the HTTP method will be there: post, put, delete, whatever method I want, mostly it's get. And the header files contain what? The header file contains the client, that is from where it is coming, what is the URL of the resource that I want to access, okay, and what are the format in which the data should be, okay, and what is the bandwidth, what is the time, etc., etc. It includes in the HTTP header, okay. And I can show you one HTTP header here. So this is just an example. So here, if I wish to see the latest news, then I'll I'll go to my browser, and now if I want to check the HTTP headers associated with my request, then right click, go to inspect element, and here in the network tab, you'll see the name of all the images or all the files associated with your search. Click on any one, and you'll see the headers here. The headers is enclosed, the URL and all the other things that is enclosed in your request, that is going to the browser or to the server from your browser, okay. You can also check if there are any cookies saved, the size, the timing of it, and the preview. You can check what is being previewed here, okay. So this is how you can understand what HTTP headers are going along with your request. So this was all for the video. If you found it useful, please hit the like button. Do not forget to share it with your friends. Subscribe to the channel. Keep learning, keep growing. Thank you very much.